Hello, good morning viewers. In this tutorial, we are going to find all the values of x that can satisfy this equation. Okay, what we are given is x squared plus x squared divided by x plus 1 to the power of 2 equal to 3. For me, I always like to clear the fractions in an equation. So let's multiply this 3 times by this denominator, which is x plus 1 to the power of 2. If you multiply by x squared, you have x squared multiplied by x plus 1 raised to the power of 2 plus, if you multiply that with this, it will just cancel the denominator, leaving only x squared, and this is equal to 3 multiplied by x plus 1 to the power of 2. Let us expand these brackets. We have x squared multiplied by, if you expand this, you have x squared plus 2x plus 1, then plus x squared outside. This is equal to 3 multiplied by x squared plus 2x plus 1. Let's distribute. X squared times x squared is x to the power of 4 plus x squared times 2x will give us 2x to the power of 3. Then x squared times 1 will give us x squared. Then we have x squared outside. To the right hand side, we have 3 times x squared is 3x squared plus 3 times 2x will give us 6x. And finally, we have 3 times 1 is 3. Let's bring every single term to the left hand side. We have x to the power of 4 plus we have 2x to the third power. If you add x squared and x squared together, you have 2x squared. As 3x squared crosses over, it becomes negative. So we have 2x squared minus 3x squared, which is just negative x squared. As this crosses over, it becomes negative. We have negative 6x. As 3 crosses over, it becomes negative as well. All we have left is 0. All right, this is a Quatic equation. But I have tried solving this without any rational solution. Therefore, we are not going to waste our time testing for the roots. Let me show you how to do that. Let's rearrange it further so that we can factorize it by grouping. All right, we have x to the power of 4. But instead of 2x to the third power, I can write it as 3x to the third power. Then minus x to the third power, which is the same thing as 2x to the third power. Then I want to leave negative x squared as constant there. Then let us add and subtract 3x to the second power. So we have negative 3x to the second power plus 3x to the second power. You know, this is just 0. It's like adding 0. As we move on, we have negative 6x. But I can write it as negative 3x, negative 3x. So we have negative 3x, which is the same thing as negative 6x. And finally, we have negative 3, and the whole of this equal to 0. All right, now we have 9 terms, but I can group them in trees so that we can factorize them by grouping. Now let us consider these terms in their descending powers of x, and also have to consider their coefficients. So let me take this. The coefficient is 1. So I want to take this. You see the power is reducing from 4 to 3. Then also I want to take this with power of 2. Then we're going to consider that with power of 3. So I want to choose this, which is 3x to the third power. Then as I come here, we have negative 3x to the second power. Then lastly, we can choose negative 3x to the first power. Then the rest, we have this, this, and this. So this is how I want to group them. So let me rewrite them. All right, by factorization, we are going to factor out the GCF. From this, we have x squared. So I want to factor out x squared. We have x squared outside. Inside, from this we have only x squared left. From this we have negative x. From this we have negative 1. Then from here the GCF is 3x, so we factor out 3x. Then inside, from the first time already 3x is out, we have x squared left. Here we have negative x and we have negative 1. Then the last group, we have 3 outside. Inside we have x squared here. We have minus x and we have minus 1. And the whole of this equal to 0. If you observe, all the terms under the bracket are exactly the same, so we can factor 1 out. So from this, we have x squared minus x minus 1. What is left here is just x squared. Here we have 3x. And last one, we have 3. And the whole of this equal to 0. So these are the two factors we have, and to find all the possible roots, we are going to solve these two factors separately. Let me start with the first one. The first one, we have x squared minus x minus 1 equal to 0. X will be equal to minus b, which is going to be 1, plus or minus the square root of b squared. You know, b is just the coefficient of x, which is negative 1. Therefore, b squared is 1, minus 4a is 1, which is the coefficient, which is the leading coefficient. Then multiply by c, which is negative 1. Divide by 2a, which is 2 multiplied by the leading coefficient. So we have just 2 here. This is equal to 1 plus or minus the square root of 4 times 1 is 4 times negative 1 is negative 4. Then we have 1 plus 4 is 5. So we have 5 here. Divide by 2. Therefore, the possible values of x here, x1 equal to 1 plus root of 5 divided by 2. Then we have x2 equal to 1 minus root of 5 divided by 2. Now let me consider the other factor, which is x squared plus 3x plus 3. All right, x here will be equal to minus b, that is minus 3, plus or minus the square root of b squared is 9 minus 4 times 1 times 3 is 12. So we have 9 minus 12. Divide by 2 times the leading coefficient, which is 2. This is equal to negative 3 plus or minus 9 minus 12 is negative 3. So we have negative 3 here. Divide by 2. And finally, you can see this is equal to minus 3 plus or minus root of 3i. So this is complex root. x3 is equal to negative 3 plus root of 3i divided by 2, and x4 equal to negative 3 minus root of 3i divided by 2. So these are all the possible values of x. We have 1 here, the second one here, the third one here, the fourth one here. So these are the real roots, and these are said to be the complex roots. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.